everybody. Today we're going to be going over the Kruskal Wallis test. We're going to go over what the test is and how to use it. The Kruskal Wallis test is used to compare 3 or more samples to determine if they come from equal populations. This is an alternative to the one-way ANOVA test for when you can't assume population has been normally distributed. Your data must be measured on an ordinal, interval, or ratio scale. Each sample should have at least 5 observations. The test statistic will be from the chi-squared distribution. So the steps to doing the actual test is first you combine the data into one large set and rank everything in ascending order. Then you re-separate into respective samples and sum the rank columns. Then you plug those values into the formula to determine H. You compare H to the chi-squared statistic to reject or not reject your hypothesis. So consider the example. The hospital system of the Carolinas operates 3 hospitals in the greater Charlotte area. The Director of Administration is concerned about the waiting time of patients with non-life-threatening injuries that arrive during weekday evenings at the 3 hospitals. Specifically, is there a difference in the waiting times at the 3 hospitals? The director selected random samples of patients at the 3 locations and determines the time, in minutes, between enter the particular facility and when the treatment was completed. So as you can see right over here, we have our data set. There is 3 columns, and each of them has at least 1, 2, 3, 4, 5, and then more. So it does tick all our boxes that we can use the Kruskal Wallis test. So we're going to do our hypothesis test. So first you have to set up your null and alternative. So your null will be that there's no difference in the waiting times between the 3 hospitals. Your alternative hypothesis is that there is a difference between the waiting times in the 3 hospitals. We're going to use a 5% significance level. So for step 3, we have to come up with our test statistic. So first we have to decide how many degrees of freedoms. Well, there's 3 columns, and degrees of freedom is going to be equal to k minus 1. K is the number of columns, and then minus 1. So 3 columns minus 1 equals 2. So we're going to go right over here to our little chi-squared chart, and we're going to pick out 2 degrees of freedom at 5%, and that is going to give us 5.991. So our chi-squared test statistic equals 5.991. So our decision rule is going to be we're going to reject the null hypothesis if H is larger than 5.991. So now we have to calculate H. I took my data set and I put it into an Excel sheet to do all my ranking and totaling, because you could do it by hand, but it'd be a rather long and tedious process. So as you can see, I've put everything into an Excel table, and I combined everything to rank it, and then I separated it all into 3 columns, so like rank column 1, rank column 2, and rank 3. I totaled them up at the bottom, and I also counted the numbers in each sample, because you're going to want those numbers for the formula that's coming up. So hold on to these numbers because we're going to use them in just a second. At last, here we have the formula to calculate H. As you can see here on the side, I've put our important values down. And what we're going to do is we're just going to take those values and plug them right into the formula. So I'm just going to take a second to write those down. So once you've filled out your formula, we're just going to take that whole thing and punch it into our calculator. Most likely you'll probably want to do it in a couple steps. Just make sure to keep everything in line. And our calculator will give us the value 5.38. So if you recall from just a little bit earlier, we discovered that our chi-squared test statistic was equal to 5.991. So our H is actually smaller than our test statistic. What this means is that we will not reject the null hypothesis, and what that means in terms of the actual hypothesis testing is that there is no difference between the populations that each of the samples came from. So according to this test, all the populations are equal. And that's the whole thing. Thank you for watching.